Blurb 10, Power of 10 notation and answer significance. You wouldn't have be taking physics now if you hadn't had a power of 10 notation in math. So just as a reminder, placing a number's decimal location so that it lies between 0 and 10, multiplied by a power of 10, is called the power of 10 notation. If the decimal point of the original number is moved to the left, it makes the prefix number smaller, and the power of 10 is larger than 0. If the decimal point moves to the right, making the prefix number larger than in the original number, then the power of 10 becomes less than 0. So for a number like 345.6, in order to make it a power of 10 notation, we'd move the decimal point 2 places to the left, and the prefix number becomes 3.456 times 10 to the power of 2. The 2 represents the move of two decimal places to the left. Now, in use of the web, the power of 10 notation has a shorthand that is kind of useful in physics, at least to me. And that would be that instead of writing it all out as times 10 to some power, you could really use a letter like E to represent the exponent of 10 being 2. So the number that we just had in power of 10 notation as used on the web, because it cannot be easily done to make the 10 to such power, they would say 3.456 E2. And that's how we would use it in physics calculations, because the calculations of physics do not require units. If, however, this same number was used in data or an answer, then it must have the required units. And in this case, I just put centimeters to represent that fact. Sometimes a small e is used instead of the capital letter E, and using this shorthand. It really doesn't matter. It's just a quicker way of writing numbers in this notation. All right, so the rule of significant digits in physics, very important rule of how you form your answers. When solving a physics problem, look at the numerical data and determine from it which data has the least number of significant digits. The numerical answers to a problem may not have any more significant digits than this. And the rule is the answer to a physics problem involving measured numbers is limited to the least number of significant digits of the data used in the calculation of that answer. All right? So we use an example. If a bird flies 100.0 meters in 12.3 seconds, what is the bird's average speed? The formula for average speed is just distance over time. The distance in this case is 100.0 meters, which is 4 significant digits. And the time is 12.3 seconds, which is 3 significant digits. So we know right away that the answer can have only 3 significant digits by the rule of least significance. If you calculate 100.0 over 12.3 on your calculator, you get a long string of numbers. However, by the rule of physics, measured numbers, you would have to cut it back to 3 significant digits. So the answer in this case would be 8.13, and then you would, because the calculations can take place without units, you would have to add the units. And if you recall, speed, base units of speed in the SI system, and the SI system is the system we're using, the SI system has base units for speed of meters per second. So we would add meters per second to our 3-digit answer, and then we would make the final mark the answer rule. So we would put something to mark it. In this case, just use an oval.